Okay, this is section 4.5 right here. We're going to solve quadratic equations by finding square roots. So before we can actually start solving them, we've got to talk about actually square roots. So if r squared equals s, then r is the square root of s. So if I take the square root of this side and the square root of this side, you have r equals the square root of s. And that would look like this. R equals the square root of s. So a positive number actually has two square roots. One is a positive square root of s, and one is a negative. So then we have negative square root of s. The principal square root is the positive square root, so that's the main one. That's what we call the principal square root. So a radical is an expression of this form. We're going to have really a 2 here. That would represent the square root of s. Or we could sometimes put other numbers, so I'm going to write an n. And for this, s is a number or expression, and then the symbol, that's our radical sign. And then we might make this right here a different number besides 2. When there's no number written here, it's a 2. When there is a different number here, like maybe a 3, that would be the cubed root. Or we could put a 4, that would be the fourth root of s. The cubed root of s would mean what times itself 3 times gives you that value. A radicand, another word here, that's the number or expression beneath the radical sign. And you talked about that last year in Geo. So there's two properties of square roots. They're used to simplify expressions with square roots. Our two properties are the product property and the quotient property. So if I have the square root of a times b, I can split it up into the square root of a times the square root of b. And this is only provided that a is bigger than 0 and b is greater than 0. Our quotient property is the square root of a over b equals the square root of a divided by the square root of b. And again, a and b both have to be greater than 0. So right here it says a square root expression is considered simplified if, so we've got two things that make us, let us consider things a square root simplified. So the first is no radicand has a perfect square factor other than 1. So the radicand is the number under the radical, and it can only have 1 as the only perfect square factor that goes into it. And the other thing is there's no radical sign in the denominator. Of a fraction. So the bottom of a fraction cannot have a radical sign. So let's look at some problems. Okay, we're going to do simplifying. And we want to look for the two things. No radicand has a perfect square other than 1, and then there's no radical sign in the bottom of a fraction. So right here, square root of 75. Well, my perfect square numbers, let's talk about what those are, first of all. My perfect squares are 1, because 1 times 1 is 1, 4, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81, 100, that's 10 times 10, 121, 144, 169, so I got up to 13 times 13. And they obviously keep on going. But those are our perfect squares, and that's what this is talking about right here. Those numbers cannot go into the radicand. And for number 1 here, 75, well, I know right away, doesn't 25 go into 75? It does, and that is 3 times 25. So I'm going to split it up and put my square root first. That's the square root of 25, I'm at the perfect square first, times the square root of 3. The square root of 25 is 5, and then the square root of 3 we cannot simplify, so it just stays 5 square root of 3. And that's my answer because I have no perfect square that goes into the radicand. The radicand is 3, and there's no radical in the bottom, the denominator. Well, there is no denominator. The next one, 98. Well, 49 goes into 98, and if you didn't know that right away just by looking at it, you could try it in your calculator. 98 divided by 4, 98 divided by 9, 98 divided by 16, 98 divided by 25, and so on until you find a perfect square that goes into it. Now, if you did 98 divided by 64 and it didn't go into it, obviously there's going to be no further numbers that would go into it. So 98 is 49, so that's the square root of 49. And it's 49 times 2, so square root of 49 times the square root of 2. The square root of 49 is 7, the square root of 2. And there's my simplified answer. Number 3, well, I know from up above, I can break this up and give that square root to the top and bottom. So I can make it the square root of 100 over the square root of 169. Well, the square root of 100 is 10, the square root of 69 is, or 169 is 13. 10 over 13, nothing goes into both of those, so 10 over 13 is in reduced form. Next one, the square root of 7 times the square root of 35. Well, there are no perfect squares that go into either of those two numbers, but what I do notice, square root of 7 and 35, I can make that the square root of 7 times the square root of 5. Now, the square root of 7 times the square root of 7, isn't that the square root of 49 times the square root of 5? And the square root of 49 is 7 times the square root of 5. And you could skip this last step right here. You could skip that and recognize that this would just simplify to 7. So number 5 here, one thing you need to remember is that multiplication is commutative. You can switch the order. And it's really like there's a multiplication sign in here and in here. So I can make this 2 times 6 times the square root of 8 times the square root of 28. That's no problem flipping that around. 2 times 6 is 12. Now 8. 4 goes into it, and 4 is a perfect square. So I can make that the square root of 4 times the square root of 2. And 28, 4 goes into that one as well. So that's the square root of 4 times the square root of 7. And so now I've got 12 times, well, the last problem, didn't we recognize the square root of 4 times the square root of 4? That would just give me 4. And then I've got times the square root of 2 times the square root of 7. And then we want to combine these a little more. 12 times 4 is 48 times the square root of, let's put our two radicals back together. 2 times 7 is 14. So it's 48 times the square root of 14. And there's my answer. For number 6 here, we've got this 3 in the front, and we should recognize by this point square root of 6 times the square root of 6 is just 6. So I have 3 times 6, which is 18. So my answer is 18. So here's some simplifying. Hopefully you've seen these at least a little bit before. We usually cover them a little bit at the end of Algebra 1. But there's some simplifying. So now let's use these square roots to solve quadratic equations. I'm going to move my screen up a little bit here so I can look at the bottom of this page. Okay, so if the equation only contains x squared, or in parentheses, x plus a number, the quantity squared, then we isolate or get alone the square root portion, or the squared portion, and take the square root of both sides. Okay, so this only has an x squared, so I need to get it alone. I need to move the 15 over here and the 2 over here. This has y minus 6, the quantity squared. So I'm going to get this whole thing alone by moving the 3 over and the 1/4 over. And then I'll take the square root of both sides. All right, so let's do this problem. As I said, I just need to move the 15 over first, so I'll do that by adding 15 to both sides. You notice my pen is much better on this video. I figured out how to fix it. So I have 80 equals 2x squared. Divide both sides by 2. X squared equals 80 divided by 2 is 40. Then I need to take the square root of both sides now that I've got that x squared alone. So x equals, now I need a plus or minus, because remember square roots have a positive answer and a negative answer. And 40, I noticed right away, 4 goes into 40, and 4 is a perfect square, so I need to simplify it. It's the square root of 4 times the square root of 10. So I have x equals positive or negative, square root of 4 is 2 times the square root of 10. And we got to ask ourselves, are there any perfect squares that go into 10? Well, 4 doesn't, 9 doesn't, so no perfect squares go into it. This is our final answer. So let's try the other one. Again, I need to get that y minus 6 squared all alone, so I'm going to move that plus 3 first by subtracting 3. So I have 1/4 times the quantity y minus 6 squared equals 11 minus 3 is 8. So to get rid of that fraction, I'm going to multiply by the reciprocal. So those will cancel. I have y minus 6, the quantity squared, equals 8 times 4 is 32. Now that I've got my squared portion alone, I need to take the square root of both sides. So I have y minus 6 equals, now I took the square root, so I need to add a positive and negative in there. And I think what perfect square goes into 32? Well, 4 does, but 16 is even bigger and 16 goes into it. So I'm going to put 16 into it. So it's the square root of 16 times the square root of 2. And if you put 4 into that, you would just have to reduce 1 extra time. So I have y minus 6 equals positive or negative 4. Square root of 16 is 4 times the square root of 2. But y is not alone yet. I haven't gotten y alone. So I need to add 6 to both sides. So I have y equals, now I'm going to write this twice for you. I get 6 plus 4 times the square root of 2, or 6 minus 4 times the square root of 2. So you should definitely go through and check this the way you would want to check this. Put this in your calculator and get a value. And do 1/4 times the quantity. Put your answer, minus 6. Close your parentheses and square it. And then add 3. And you should get 11. And then for this one, put it in your calculator and simplify it. You'll get an answer. It'll be a decimal. Keep that decimal right in there. And then you would want to put into your calculator on the next line 1/4 times, open the parentheses, do second and answer to put your y value in here, minus 6, close your parentheses, square it, then add 3, and you should get 11. And if you couldn't follow that, we can talk about it in class tomorrow as well, but we should definitely talk about how to do your checks. But here's your right answer. All right, let's look at the next page. So we have got an IROC question here. We've got a science application. So the height of an object dropped, or the height of a dropped object on Earth can be approximated using this formula. So h equals negative 16t squared plus h sub 0, where h is the height in feet, t is the time in seconds. H sub 0 is the initial height in feet. If you drop an object off the roof of an apartment building that is 240 feet tall, how long will it take the object to hit the ground? So our I, we've talked about what I means. I means interpret, and not only interpret, but also then give your solution. So we have 2 points for that first I, interpret, and then give your solution. So looking at this question, if I look through it, what I think, okay, I'm going to drop an object off an apartment building 240 feet tall. I know I'm going to have to use the equation they give me. And I'm trying to figure out how long it will take to hit the ground. Okay, so I determined that I need to use h equals negative 16t squared plus h sub 0 to figure out how long it will take an object dropped from a height of 240 feet to hit the ground. Okay, so that's what I am trying to do. I've interpreted the problem. I'm going to go back and put my solution in a little bit. So I'm going to show my work. The R's are for showing our work. I'm going to do it in a different color just so it stands out a little bit better. And the first R I want you to remember is to define your variable. So they're already given to us. It should be easy. H equals our height in feet. Okay, and that's our final height in feet. So we want it to hit the ground, and if it hits the ground, that height is going to be 0. Okay, so I'll put 0 here. Our next variable we have is time, so t equals time, and it tells us up above that's in seconds. And then our last one, h sub 0, equals our initial height. And that's where I'm starting at. That's in feet. And this problem tells me I'm dropping it from a building 240 feet tall. So my h sub 0, my initial height, is going to be 240 feet. So I'm going to plug these into my equation. My equation they give me is h equals negative 16t squared plus h sub 0. And I'm trying to find the t, so I know my capital H is 0, equals negative 16t squared plus my h sub 0 is 240. So I've got an equation. It's got a t squared in that, so I know I need to solve for t squared. I did the first r, I defined my variables. Now I'm working on the second r, and that's showing my work. So I'm going to subtract 240 from both sides. Okay, I'm going to put an arrow over here, so I'm going to move this over. So I have negative 240 equals negative 16t squared. Divide both sides by negative 16 to get that t squared alone. Okay, to negative 240, I'm going to move this over again, show an arrow. I'm just running out of space here. Negative 240 divided by negative 16 is 15 equals t squared. If I take the square root of both, t equals, now it's plus or minus when I take the square root of a negative number. And I'm talking about a time. So it's okay to have a decimal in this instance, and if you do that, you get 3.873. Now, negative though, 3.873, does that make sense? Can we have a negative seconds? No. So our t, our time, is 3.873 seconds. Okay, so I've shown my work. The last r is supposed to remind me, is it right? So do your check. So you should go through and do your check. And I didn't leave myself a lot of space, so I'll put an arrow up here. Your check, this would be your 5th point for the work section, for the r's. Our check would be 0 equals negative 16 times 3.873, the quantity squared, plus 240. And if you plug that into your calculator, you won't get exactly 0 because we rounded, but it'll be very, very close to 0. So it'll show that our answer is right. So let's go back and add to our I have determined, our first I, because we need to include our answer in that first I. But I need to use h equals, and I get my equation to figure out how long it will take an object drop from a height of 240 feet to hit the ground. I found it will take 3.873 seconds. So there's the second part. I included my answer. So there's my second part for my first I. My O, on the other hand, a person may make a mistake. So this is where we need to show where they would make a mistake and actually give an example for it. And the biggest thing I can think of where a person would make a mistake here is that 240, they would automatically assume that that's the capital H. So they would mix up their numbers. So on the other hand, a person would make a mistake. Let me change my pen color here. By using the wrong numbers in the equation. They might put, and instead of having 0 equals that, they might say 240 equals negative 16t squared plus, And then they might get lost what this last one was, so I'm just going to say plus 0. So there'd be our thing that they could do wrong and an example of it. So in conclusion, so here's one point. I just need to restate my answer. Okay? If an object is dropped from a height of 240 feet, it will take about 3.873 seconds to hit the ground. All right, and there's my IROC using the score, the rubric, making sure I have every single point that we're supposed to have in our IROCs. Please make sure if you have any questions on these notes, you star them so that we can talk about them in class tomorrow, and have a great night.